Monomials. So when you multiply monomials, there's specific rules involved that will help you. First of all, I want to go over example 1's rule. And they say something to the effect of a times a number, a to the nth power times a to the, I believe they use a different letter, m, is equivalent to the sum of the exponents over the base. Okay? And what that literally means is something like this. This is example 1. You're already doing this. Example 1, the first one is x cubed times x to the 5th, which literally means x times x times x multiplied by x times x times x times x times x, right? So here's 5 of them, here's 3 of them. The result, of course, is x to the 8, which is the sum of all those x's. Darn tootin'. Yep, exactly right. Letter B is the exact same thing. And I'm not going to draw 7 b's. B to the 7th, B to the 4, B11. Okay? B to the 11th. Okay? When you start throwing numbers into the game is when you might think it's difficult, but it really isn't. Example 2 shows us that you can use the commutative property to move your numbers around so that you multiply your numbers by each other and then you're left with your letters, your variables. Here's what I mean. I'm going to commute the 3 so that it's next to the 4. 3 times 4. And then I'm going to be left with n2 and n4. The result is going to be 12 and 6, because remember, you're just adding the exponents there. The like base, add exponents. Okay? 12n to the 6th. The rest of these examples just take it to a little bit further level, a little bit more difficult. Example 3. This one we're going to do a little commuting as well. 3a cubed b squared multiplied by 5ab to the 4th. And remember, it's the same base where you add the exponents. So for example 3, I'm going to group my numbers, negative 3 times 5. And I'm going to cross them off just so that I don't forget that I've already dealt with them. Then I've got my a's, a cubed and a to the 1st in the list. And then I'm going to put my b's in the list. B squared, b to the 4th. Okay? So I took the parentheses, the 2 factors, and I listed them in a commuted order so that they get grouped together the way I want to multiply them. So you end up with negative 15, A4, yep, B6. That's it. Yep. Very good. Yes, yes, yes. Okay. The next one. Just because it's in fraction form doesn't change how we are able to do this. Okay, how we're able to do this. You might not catch it right away, but I actually think example 4 is kind of cool. So 20x squared y divided by 3 multiplied by 12x cubed y 5 divided by 5. Okay? Now I am going to convert this or mix it up by taking my fraction, my numbers, and multiplying those together first. And notice the variables are in the numerator, so those stay in the top line, if you will, of the fraction. And I'm just going to group those on the top. X squared, x cubed, y, y5. Now that's not how they show it, but this is how I would do it. They just showed it like as if it's equal, but it's actually in the numerator line. Now, like normal multiplication of fractions, we can do some cross-canceling here. That becomes a 1, 4, 1, 5. So you should get, numerically, you get a 20. X's.
16.
5 goes into 24 times. 16, hallelujah. X2, X3 is X5. Y1, Y5, Y6. Yes, ma'am. And sir. Very good, very good, very good. Not too bad, right, guys? The fraction ones, I think, are the scariest, and don't even worry about them. I want to look at number 23 with you, because that's another example of a fraction. I think if there's anything that you might be scared of, it might be that. Is there anything up here you guys felt like was a little awkward? No? All right. Let's do 23 together. And notice I didn't start you till 18, because I'm not going to make you do the really easy ones. I know. So this is number 23. See if I can do the math. 15a cubed b over 2 is being multiplied by 8ab squared over 10. Separate the numbers, which would make it 15 over 2 times 8 over 10. And then I would group my letters by type. A cubed times A, that's these guys, and B times B squared, and that's those guys. Yes, ma'am. You're already jumping it. Very good. 5 goes into that twice. 5 goes into that 3 times. 2 goes into this once. 2 goes into this 4 times. And notice here and here, the 4 and the 2. Can't we reduce that as well? Mm-hmm. That becomes a 1. That becomes a 2. So don't be afraid to look for those opportunities as well. So you end up with 6A4B3. Okay? Good? Not too shabby, folks. All right, if anything comes up while you're